Welcome to lesson 7.3.3. What if the data is not numerical? So what we're going to do today is we're going to talk about an association between categorical variables. This is called bivariate categorical data. Bivariate being two variables, and the categorical just means in categories. So one of the things that I enjoy talking about here in class, because we are a rural community, oftentimes we will take a poll inside of class to see where do students land. Okay, so in these categories you'll notice we have people who live on less than 1 acre versus more or equal to 1 acre. So if we were taking this poll in class, I would personally mark right here because I live on more than 1 acre and I have livestock. Livestock being pigs, sheep, goats, horses, cows, chickens. And what we did is in class we went ahead and take a poll and then we calculate the percentages, and the goal is to see, is there a relationship between how much land you have and whether or not you have livestock. And I want you to notice, people who live on less than 1 acre have livestock? Nope, no they don't. Versus no livestock, there's a significant percent of people who live on less than 1 acre and they have no livestock. Okay, this is a very confirming fact. Whereas the people that do live, we had 6 up compared to 2. And so here's a good example of maybe there is a connection between how much acreage you have. Now, what I would like you to do in your notebook is you are going to, first of all, pause the video and record this table. Everything you see, write in the table. Pause the video now. Okay, now that your table has been copied, down below, I want you to write this sentence. This chart shows there is a slight, that's S-L-I-G-H-T, a slight relationship between having acreage, that's A-C-R-E-A-G-E, acreage. There is a slight relationship between having acreage and having livestock, period. If you need to re-listen to that, feel free to go back and listen to that sentence again. Make sure that you have it written down just below this table. Now, this isn't the problem that we did. That and this problem is another problem that we did in class. Problem 7-107. The experiment students did with plants in different growing conditions in lesson 713 caught the attention of a local farmer. He was interested in whether the type of soil made a difference in the height of his corn crop. He planted 2,500 stalks of corn and collected the following data. This type of table is called a frequency table because it shows counts or frequencies in each of the cells of the table. So you'll notice that you have a table that matches these numbers in your notebook. And sometimes when you look at this raw data, this is called raw data, it is oftentimes difficult to calculate. Now, in class, we added an online assignment to this in Google Classroom. You are not responsible for that. We are going to just look and try and figure out what this means, okay? Now, when we look at this type of information, it's oftentimes hard to decide, is there a relationship? Is there not a relationship? Because of the raw numbers, okay? And so what we're going to do is we're going to go ahead and take this information, and I walk students through, how do we find the percent? Well, if you had a calculator, you would be taking the total number, let's start with this number, and we would divide it by the total. We would take this number and divide it by the total. And that's a lot of calculation that we can do. And so we went through an Excel or sheet option in writing an equation in order to create a percentage. And I'm going to go ahead and show you that table now. You'll notice that we have the percentages here in front of us. You do not need to record this information. We're just going to figure out what should this corn farmer do. Now, once again, these percentages are a little bit more helpful because we can compare apples to apples a little bit better. But more than a table, oftentimes it's more helpful to see a graph. And so on your notebook, you'll notice down at the bottom, you have two graphs. And I want you to copy these two graphs right now. Pause the video to copy these two graphs into your math notebook. Okay, you have these two copied into your math notebook down at the bottom. And what we're going to do is we are going to put the clay and sandy soil bar graphs into our math notebook. So please pause to copy these bar graphs into your math notebooks. All right. Now, what does this mean? Well, if I look at this data here in my bar graphs, I notice that 34 plus 45, that kind of looks like a time symbol. 34 plus 45 equals 79% good, yes, you copy this, producing stalks. S-T-A-L-K-S, I think, stalks, okay? Whereas over here in the clay soil, we have 24 plus 30 equals 54% of good producing stalks. So you want your corn stalks to be, taller stalks of corn in order to produce multiple ears of corn. Good producing stalks. S-T-A-L-K-S. Okay? So what does this tell us? Well, ultimately, you should be able to notice that sandy soil yields a better corn stalk. So let's go ahead and write this sentence. These bar graphs show us that sandy soil yields, Y-E-L-D-S, yields a better corn crop than clay soil. Please go ahead and write that down in your math notebook so that you can have the realization of what this means. Okay, ultimately, when we look at a frequency table, it is difficult to see the difference. And that's why we go ahead and create a bar graph to go ahead and show what is really happening here, and we can make a decision based on that. Thank you, students, for coming to lesson 7.3.3 when we're looking at bivariate categorical data. Have a wonderful day.